Okay, so I'm gonna go through this final and specifically like walk y'all through how I would do it and also what I was looking for when I was grading it. So, question one, we're given a graph. What is this a graph of? Well, it tells us this is a graph of f prime. Sorry, I'm having some syncing issues, so I'm gonna try and make sure everything's showing up the way I want it to. And before I even scroll down and look at the question, let's look at this graph and let's figure out everything we can figure out. This is f prime, so what can we figure out? Well, if I look here and here, these are our critical points because this is where our f prime is 0. At -1 and 3. If I'm looking at the graph, I can also tell that there's a vertex right here. So we have a horizontal tangent line there. And what does that horizontal tangent line mean? It means, well, it possibly means that we're switching from decreasing to increasing or increasing to decreasing. And if we look, that's actually what's happening. We'll notice here, on the left side of our tangent line, we're decreasing. And on the right side, we are increasing. Okay, so now we have pretty much all the information we can figure out from our graph. Let's scroll down. Let's actually look at our question. Let's look at our information. F is a twice differentiable function. What does that mean right there? Twice differentiable. This twice differentiable means that F is differentiable twice. Very intuitive. Mathematicians like to choose very obvious things for our names sometimes. It means it's differentiable twice. What does that mean? It means that, well, because f is differentiable, f is continuous, and because f prime is differentiable, because it's differentiable twice, so f is differentiable, f prime is differentiable, that means that f prime is continuous. So that's the information I'm getting right there from this specific statement. Okay, moving on that interval, that's just the interval of our graph, blah, blah, blah. F of 1 equals 2. I don't know what to do with that yet, but it's probably going to be important. So I'm just going to put a little highlight on it. And then it says the graph of f prime, the derivative of f is shown above. We already know that because it labels our graph as f prime. Nothing new there. The graph of f prime crosses the x-axis at -1 and 3. We already noticed that because we already said those are our critical points and has a horizontal tangent at x equals 2. Boom, it just told us some things we could have already just seen from the graph. So all this stuff here, this stuff is just extra. It's helpful if you don't notice it on the graph, or maybe you want to argue that at like the vertex isn't super clear, but we can see it from the graph. And I have a typo here. It should have said let g be the function given by g of x equals e to the f of x. Okay, before I do anything, I want to notice some things about this function here. So we don't have a lot of information about g, a part that is e to the f of x. And what we can tell, well, we should know, theoretically, which, actually I take it back, it's not that we should know, it's that moving forward, we should know that e to the x is continuous and differentiable and e to the x is greater than 0 for all x. All that we should know about e to the x. So we now have e to the f of x. Well, since f of x is continuous, because we said that earlier, since f is differentiable, f is continuous, that means that e to the f of x will also be continuous. Is continuous and differentiable since f of x is continuous and differentiable. So e to the f of x is continuous and differentiable since f of x is continuous and differentiable. And further from that, this statement, I'm not going to rewrite it, but I'll just highlight it. Just highlight it light blue. This was sort of the hint that I gave all my classes. E to the x is greater than 0 for all x. That means specifically that e to the x is positive. Being greater than 0 means we are positive. And that's a powerful tool, knowing that something is positive or negative. Okay, so this is all information I've gotten just from reading this. I'm writing this all in the paper so you can see the thoughts going through my brain, but a lot of these thoughts should hopefully start to become more kind of automatic to you when you look at graphs and text. Okay, now on to the actual question. Write an equation for the line tangent to the graph of g at x equals 1. Okay, well, equation of a line, that is our y equals m times x minus x1 plus y1. Oops, I accidentally put some stuff that I don't want. I don't know how that got there. Okay. So now we just need to find m, we need to find x1, and we need to find y1. Well, it tells us, fortunately, it tells us that x equals 1. It tells us that x equals 1, and it also tells us that we're looking for, another thing I should have pointed out sooner, but we're looking for g. We're not looking for f, we're looking for g. So, when x is 1, what is g at 1? Well, g of 1 equals e to the f of 1. And we know, because we highlighted it earlier, over here, if you can see my cursor, hopefully you can, f of 1 equals 2. So g of 1 equals e squared. And boom, we have an x coordinate, we have a y coordinate. And so now we can say y equals m times x minus 1 plus e squared. We have almost everything we need. The last thing we need is m. Highlighter's messing up. Okay. So how do we find m? Well, m is our slope. Our fancy word for slope in this class is our derivative. So let's find our derivative. And here you just need the rule that hopefully you've memorized, because I've quizzed about it a lot. We want the derivative with respect to x of e to the f of x And the derivative of e to the x is e to the x, so e to the f of x is e to the f of x, times the derivative of our exponent, so times f prime of x. Okay, and just to be really clear, this is g prime. So we found that g prime equals e to the f of x times f of x. That is one of the things that I was looking for. Let's do lilac. I like this color. That right there is 1 point. One of the 2 points was from finding the derivative. And the second point, actually, I'm sorry, I take it back. We haven't finished yet. We're missing a... We found g prime of x. But what we want is g prime of 1. G prime of 1 equals e to the f of 1 times f prime of 1 running out of space. Well, e to the f of 1, that's just e squared. And f prime of 1, if we just look at our graph, is negative 4. So we get that g prime of 1 equals negative 4e squared. This is where I should have highlighted. This right here was worth a point. G prime of 1. Okay, and now we can just substitute that into our line. We found our slope, so we have y equals rm. Our slope is negative 4e squared times x minus 1 plus e squared. Okay, second part of this question. Find all values of x at which g has a local maximum. And this one was worth 4 points. We're looking for a local maximum. What does it mean to be a local maximum? We have 2 criteria. We need g prime to equal 0. And we need g prime to switch from positive to negative. Okay. Well, how can we find that? Well, we still need our g prime, which this was actually 1 point, which if you wrote your g prime in the other question, I actually gave you this point. So theoretically, you should have started with a point on this question if you got the question there, but you should have already started by saying that g prime of x equals e to the f of x times f prime of x. Okay, so we found that. Now, we want to see where g prime equals 0. This is the tricky part. This is the tricky part in this question, because how do we know where it equals 0? Well, let's note that e to the f of x is greater than 0 for all x. This is why realizing that e to the x is greater is a very powerful thing. That means that e to the f of x will never equal 0. But f prime of x equals 0 when x equals -1 and 3. So those are the 2 points we want to look at, because we're setting our factors to 0 basically. E to the f of x equals 0, that's never true. F prime of x equals 0 when x equals -1 and 3. I got that information from the graph here and here from our 2 critical points. And now we need to prove that g prime is switching from positive to negative. Well, we've noted that e to the f of x is greater than 0. E to the f of x is always positive. So this number doesn't matter, really. We can sort of think about this as just an invisible 1, or any sort of positive number you want, really. So we're looking for where f prime of x is switching from positive to negative. Well, that would be here at -1, because our graph is positive to the left, negative to the right. So, let's write our answer now. G has a local max at x equals -1 because g prime equals 0 and switches from positive to negative at x equals -1. And let me go through and sort of flesh out where all my points were here for this. And I'll just sort of do this on my own, and then I'll refresh it so that y'all can see where my points were. Okay, so we had 4 points total here. 1 point I gave for you finding the derivative, which again, I said, if you found the derivative in part A, I would have given you the point there because you'd already found it. Part 2 was looking at your factors to find your critical points. And this was I gave you half of a point right there when I said that e to the f of x is greater than 0. If you said that, and that f prime equals 0 there, that's finding your critical points. And then a third point for getting the correct answer, saying it was a local max at x equals -1. And then a fourth point for your justification. G prime equals 0 and switches from plus to minus at x equals -1. Positive to negative. Okay. Last 2, and then I'll probably cut it off because this is a really long video. And I'll make all these questions separate videos, I guess. This one, it gives you most of the work. It does pretty much everything for you. It tells you the second derivative is this thing right here. You don't have to show that. It doesn't say show that the second derivative is that. We can't show that. It just tells us. And then it asks, is g prime of -1 positive, negative, or 0? Well, first thing we should do, let's just plug in -1. So g double prime of -1 equals e to the f of -1 times f prime of -1 squared plus f double prime of -1. Okay, and a lot of this we can sort of wash away. E to the f of -1, we don't know that, but we do know that it's going to be some sort of positive number. So I'm just going to sort of, as a stand-in, write a plus. It's going to be some positive number. And then f prime of -1 squared, well, if we look back up, we said that f prime of -1 is a critical point. F prime of -1 is 0. So I'm just going to put a 0 there. Plus. And then f double prime of -1, this also required us to use a little bit of critical thought. If we come back up here at -1, what do we know about our second derivative here? Well, this is the derivative of our derivative. What is the slope of f prime at this point? Well, we said that it was decreasing. So we need to have some sort of negative slope here. And so if I sort of just simplify this out, I'm just using, we have a positive number times 0 plus a negative number will give me a negative number. So we have a positive times a negative. And well, what is a positive number times a negative number? Well, it's a negative number. So we should have gotten that g double prime of -1 is negative because e to the f of -1 is positive f prime of x, I'm sorry, f prime of -1 is 0 and f double prime of x is negative. And really what you want to say here is justify that f double prime is negative. F double prime is negative because f prime, oops, sorry, is decreasing. And that's enough to justify that it's negative. You got 2 points for this question, 1 point for the correct answer, and 1 point for your justification. And you could have justified this in a lot of different ways. Actually, the big piece in your justification is that, well, the big pieces are you needed to say these things, that the components are positive, 0, or negative. Because that's enough to piece together that this whole thing will be negative at -1. Okay, finally, last piece. Average rate of change of g prime, the derivative of g over the interval 1 to 3. Well, average rate of change is really straightforward. G prime, I'm sorry, this is supposed to be an F. That's why I changed it. We couldn't do it unless we changed it to an F. I don't know if y'all can hear my dog barking. I think he wants to come in, but I'm going to finish this question really quick. F prime of 3 minus F prime of 1, all divided by 3 minus 1. Well, F prime of 3 is 0. F prime of 1 is -4. 3 minus 1, that's 4 over 2 equals 2. And we get our average rate of change is 2. You didn't even need a sentence here. Getting to this is your whole justification. You're good there. And really, if I'm being... once you got to this point here, if you didn't simplify it further than that, that is your point. If you kept going, great. But something I'm going to talk about a lot next semester is safe stops, and this spot right here is a safe stop. You would have gotten your 1 point there for that. Okay, I'll try and post this quickly.